Okay, so this is a follow-up on my Tig water cooler that I built. I've done a couple of videos on the building of this, and I've had someone ask me a couple of questions about it, so I'm just going to try and answer and do a little demonstration of that real quick. This should be a short video. Question number one had to do with the flow rate. He was curious how much flow it gets, so I'm going to show that, and maybe a little demonstration of the cooling capacity of it, just try and get a feel of what it can do. And the other question has to do with the hose and electrical connections that I did, why I routed them the way I did, which is a non-standard setup. And I'll get into that following up after the cooling capacity. So I'll see if I can get some diagrams of the original wiring and hose setup that's commonly done. I don't have it on hand right now. I'll probably just insert that as a picture somewhere, probably as I'm describing this right now. I'll post that up. I gotta dig it up. Okay, so we're going to start with the flow rate here. And first off, it's really cold in here right now, and this has an antifreeze in it. It's basically straight antifreeze. It's RV antifreeze, which is a form of alcohol. It's got other stuff in it, but it's probably a little thicker than water, and especially with it being so cold in here. So what I'm going to do here, I've got 1 minute counted down on a timer, and we're going to draw into this jar here, see how much comes in. So this isn't as fast as I'd like to see, but from what I've done with the TIG welding so far, it still has plenty of capacity. And we're going to put a flame on this and actually show what it really can do with this flow. So let's start with this. Okay, take the vice clamp off here. We're just going to run it into the jar as I start the timer. So this is a fairly small pump. Free load, it actually pumps a good bit of volume, but it's not high pressure. And the orifice and the torch, where it goes through the cooling loop, is really tiny. It's like maybe 3 square millimeter at most, the surface area or the cut. Okay, I gotta stop this in just a couple seconds. Okay, so this is what we got in, here we get it in view here. That's in 1 minute, what I've collected. Now this whole jar is probably about a quart, I'm assuming. So that's our flow rate. So as I was saying, the pump is low pressure. It's high, fairly good volume. If it wasn't for the restriction in the torch, it would pretty much fill this tube. I've tested it preload in a sink, and it will squirt a nice thick stream a couple feet high in the air. But the restriction really slows it down. On a commercial setup, I'm assuming they use a fair bit more pressure. They probably pressurize it to 10-15 pounds. You know, and just a low volume, but probably a little more than that. But this seems to be adequate from what I've seen. So let's get on to putting some heat into this. I do have to be a little careful here because being an alcohol, this is flammable. Okay, so I'm hoping that you can read that in the camera. just to give you an idea of what we're looking at for temperatures in here right now, and we're going to try and monitor this. So I've got this flame directly on the copper pipe with that flow going through it, and a little bit past the flame here with the fluid going through there. That copper pipe is, let's see, get it out here a little from where the flame is. The flame. And it's running maybe just a little bit over 50 degrees Celsius, well below boiling. And let's take the flame off and see what happens. We'll probably see that cooling carry through here. In fact, already, that's dropped right down. So that's the cold fluid running through there, cooling the copper down. That's from what's in the reservoir. Here you can still see a little more heat where it's come down. Hasn't reached yet 24°C. That's room temperature right there. Normal room temperature. It's cold in here. It's only about 8 degrees Celsius in here. And it was probably close to 0 overnight, which is why the water's so cold. Okay, so I'm hoping you can read this clear enough that you can get an idea what we got here for the cooling, but I think this should be a good demonstration of that. So I'm going to pause here and put this back together, and I'll go into the wiring setup. Okay, so the standard setup, I'm trying to describe this. The water cooler is a lot simpler in the standard setup. You've got your power to supply the pump and fan and all that. And then you just have 2 water fittings on the front of them typically. Now they may have quick connects, which is a help, but still doesn't solve everything in my opinion. but it makes the machine simple. So the routing on them, you have to use a special adapter up by your welder, and if I remember this right, the return from the torch will go, the water return will go directly to the cooler on one of the two fittings. The output of the water cooler, the cold water out, has a jumper hose that will go up, and it will go up to where your electrical connector is for the torch, because the torch shares the cold water goes up through the same hose that the power goes up through. They've got is a copper conductor, that stranded copper conductor that is inside the hose for the cold water coolant going up, and that's how you power the torch. It helps keep that conductor cool, and it eliminates having an extra line going up to the torch. So what you have to do is they make a special adapter that goes on your electrical connector, or replaces the original connector. Okay, so this is the small dense connector. Well, this one's kind of homemade, so it's not exact, but so do I have a regular one here? Yeah. Okay, this is a real dense. This one goes to my stick welder. So it's a fitting like this, but it's got a hose inlet that comes from the water cooler, goes up to here, and then your torch attaches to that. And then you would plug this into the welder. So it runs from the water cooler up to the adapter and then up to the torch. So you've got to run that, your lines go all the way up to the torch, all the way back, and then you have to split out and go back over to the water cooler. And either you have quick connects or you have the actual manual connections, which is completely open.
Correction. Actually, the dense connector and the power line are with the warm water return.
No, that's fine. If you have a dedicated TIG welder, that's all it does is TIG, and you leave your torch set up to it all the time. It's not that big of a deal. Of course, you always have to have your water cooler right next to your TIG welder. You probably want it incorporated into the car. But if you have to break it down, it's a pain in the neck. You have to undo all these connections. A little better with quick connects if they're the type that don't leak when you take them apart. They always leak a little, but at least it's not losing all the fluid and open. If you've got just regular pipe connectors or you twist it on, the thing's going to leak every time you take it apart. You got to drain everything. Just a lot of pain in the neck. And even with the quick connectors, they don't last forever. The things wear out in like 6 months. And to me, it's not a graceful setup. As I said, for a dedicated welder, if it's left hooked up all the time, okay. But this is a combination unit. It also does stick welding and it does plasma welding. And there's a lot of American machines that do the same thing as this. They're quite prevalent now. And when you have that, the thing is you're constantly changing your connections every time you change operations. And I don't want to be breaking the coolant circuit every time. Plus, I don't want to have this thing always attached to my TIG welder. Because I may want to use this for plasma cutting and I don't have to drag everything else around. So I don't, instead of doing that setup, my torch is always attached to my water cooler down here. So I've got the 3 lines down here with the water return, the water out with the power, and and I forget if I get this in the right order here, and the gas would be the last one. And I always leave that attached to the torch, so I never have to break the coolant system. The only thing that I do to hook this up, and it's much quicker. So right now I've got my plasma torch is on this. So undo my connections for my plasma, and I had this finger tight before. I have to speed this up. So we undo that. And I've got my power lead that goes to my coolant unit down here. And we plug that in down here. And on gas line. So this one is a gas line. We get that screwed on, and I'm all set to go except for changing the settings on my welder. Everything else is done. It's that quick. I don't have to deal with losing coolant, fiddling with a whole bunch of hose connections and all that. 2 lines, done and over. So that's why I've got a little more invested into the build of this cooler, because it makes it a lot simpler in operation later on. To me, it's just a lot more graceful setup. So that's pretty much it. Thank you for watching. If you've made it this far, I hope you've enjoyed watching this video and found it entertaining or educational. If so, please consider hitting like or subscribe. It does help give me incentive to continue producing more. Thank you.